absolute value and piecewise graphs. This should be review, so hopefully you've learned all of this or something very similar to this in Algebra 2 and your other previous math classes. So we'll start off by talking about the absolute value function. The absolute value function, when we write it out, we use those vertical bars. It could be written using function notation as well. Let's just start. If we had a table of values, we know that we would fill in only positive values. And if you graphed those points and then connected them and extended them, you would get a graph that looks like a V with its vertex at 0, 0. You could think of it as two separate graphs, almost like a piecewise graph, which we're going to talk about in a couple of minutes, where we have a slope of +1 for the positive values and a slope of -1 for the negative values. But it's probably just going to be easier for us to think about that V. There's a general form of this where we can talk about what these different letters are and how they affect the graph itself. So we have the A and B values, which we don't always use the B value. Usually if we're going to have a coefficient, it's outside the absolute value. But you could have a -1. So we need to know the difference that if we have a negative B value, it's going to reflect over the x-axis. And if you had a negative A value, it reflects over y, which you can tell, since we have y-axis symmetry, wouldn't matter unless the graph had moved. Like, for example, if it had shifted. Then when it reflects, it will mirror over the y-axis. The H and the K give us a horizontal and vertical shift. Be careful here with the sign. If the number inside here is being subtracted, then we're going to move to the right. And if we are adding H, we're going to move to the left. So if we have x minus 1, that's 1 to the right. And if we have x plus 1, that's 1 to the left. If we take just the h, just the number being subtracted, and take it with k, that will give us our vertex, or the point of the graph. So a couple of quick examples here. Let's take this first one. Switch colors. Our parent function is going to look like this, where we have +1 and -1 as our slope. Should be right at 0, 0. So if we have a +4 on the outside, that's going to shift our graph up. And it's going to shift it up 4 units. Everything else about the graph will look the same. So jot down that example I'm about to erase and look at the second example. For example number 2, here's our parent function. This tells us we have a coefficient of 2 and we have a -6 outside. So this is going to make us go down. This is going to compress. It basically changes the slope. So if this is the slope, or if this is the line y equals x, now we're going to have the line y equals 2x. And we have y-axis symmetry, so it gets mirrored over the y-axis. But then we still have to move it down. So our final graph is going to look something like this. this one right here. Piecewise functions. We're going to define piecewise function as different equations used for different intervals of the domain. So if we think about the critical points, what we should be looking at here are the transitions between those intervals. So we have a critical point at 0, 5, and 8. So those are important points of the graph that will help us get an accurate sketch of the graph. If you have a quadratic involved, you have to also think about where the vertex of the quadratic. We could also have absolute value and look at the vertex of that as well. So to graph the piecewise, we're going to find the coordinates at the endpoints, both at 5 in the first equation, and then we also need to plug 5 into the second one, and we'll also need to find 0 and 8. So let's look at this one. We're going to plug in negative 2 times 0 plus 3. So we have the point 0, 3, and it's a closed point. We have negative 2 times 5 plus 3. So at 5, we'll be at negative 7, and this one will be open. Then we will have plug in 5 into 5 minus 12, which also gives us negative 7. So now we're going to just fill in that hole. And 8 minus 12, which gives us negative 4. So our graph starts here, connects down to the negative 7, connects up here. Open holes at, closed holes at each point. So think about this one on your own. You might need to sketch the graph. We want to know if the graph is continuous at 3, meaning do you have to pick up your pencil at 3 if you were tracing it. I'd also like to think about what the value of 5 will be in the function. Answer that into the Google Doc and make sure you let me know if you have any questions.